All right, we're here with Unit 3, Lesson 4, Comparing Proportional Relationships, and Math is Good. Now, we're starting off with these proportional relationships. I want us to remember that we have proportional as one of our vocab words. So, proportional is always linear, it has the same slope, it has the line goes through the origin. And I think yesterday we also explored some idea about how the x and y values of proportional relationships, like if these were like this, you might have some like scale factor multiplier across that's the same as the slope. So this might be like 2, and then this would be 4, and then this would be 6. Like it's a times 2 times 2 times 2. And it turns out that's the same as my slope because this is a plus 2, this is a plus 1, and then my rise divided by my run there, that would give me a rise and run of 2 over 1, which is a slope of 2. So that's a little bit of a review of what we saw yesterday. Now we're starting off with 4.1, what is the relationship? We're going to do these proportional relationships 3 different ways today. We're going to do equations, tables, and graphs. Starting off, describe the situation that could be represented by this equation. What do the quantities x and y represent in your situation? Well, in this way, let's think of a story. We're growing some plants, plant growth, and we could think of plant growth after some time. So maybe x could be my time. So let's say x is every month. So I could say x equals months, and then y could equal the height of the plant. And then that would mean that this 4.2, let's just say it's 4.2 centimeters per month. So each month I would going to be adding 4.2 centimeters. Now, as I go along here, it says create a table of this example. I'm going to scoot up. So I can make a table of my x and y. I could pretend, hey, I have, remember in my story, this is like months, and this is height in centimeters. 0 months, 0 height. Again, it's a proportional relationship, so it's going through 0, 0. So then 1 month, well, if I plug 1 in to my y equals 4.2, I put a 1 in there, that's going to give me 4.2. If I put a 2 in there, I get y equals 4.2 times 2. That's going to give me 8.4, I believe. Let's check. 4.2 times 2. 8.4 is correct. I'm going to put a 3 in just to be thorough. And I would have y equals 4.2 times 3. And that's going to give me 12.6, I believe. You could check with your calculator. 12.6. And then maybe I could put in, like, I'll jump a few. I'll put in a 5. 4.2 times 5. I'm just plugging in. These are my x values. Remember, my equation looked like this at the beginning. This is my equation. These are my x values that I plug in here and here and here and here. If I put a 5 in, put a 5 there, I get 21. Now, let's go ahead and label my graph here. My x values, we're counting my months, and my y values are counting my height. I don't know why I'm misspelling height each time in centimeters. And looking at this, I want to get to a height of 21. So I'm probably going to jump by, oh, I don't know, maybe fives here. Let's see how far we get. 5, 10, 15, 20. Probably could have jumped a little bit higher here. And then I have my 0 months. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go ahead and put these dots on there. So 0, 0. 0, 0 is going to be here. 1 and 4 is going to be about there. 2 and 8 is going to be about here. 3 and 12, so 12 would be about here. 3 and 12 around there. And 5 and 21, I'm jumping up 5 and 21. Are these all staying on the same line? It does look like I'm graphing nicely. And so using this, we could actually use my graph to do some predictions. So at 10 months, I would expect to go up here, and I'm right there. This is how tall my plant might be after 10 months. What number is up there? So this would be 25, 30, 35, 40, and maybe like 42 or something like that. 42 could be my height of my plant when I go that tall. Let's go to 4.2. We're going to do some comparisons. Elena babysits her neighbor's children's. Her earnings are given by the equation. So we have another equation here. Now, if this is her earnings, let's see. I bet Y is going to be money, and X is going to be some sort of time, or maybe the number of times she babysits. So let's see. X represents the number of hours. So X is hours. And Y represents the amount of money. So we did guess this right. So my Y is money. Jada earns $7 per hour mowing her neighbor's lawns. So let's make some models here. We are going to do Elena, and we're going to create a table for Elena, an X and Y table, and we're going to create a table over here for Jada. Let's see, I bet I want a graph as well for Elena, so I'm going to have a graph in this area, and then I'm going to have a table over here. So I'll have a graph here, X and Y, and then for Jada, I'll have her table here. It looks like I'm running out of room to create a graph for this one. Maybe I can graph them both on the same graph. That could be cool. All right, so I have my equation for Elena. I have Y equals 8.4x. So I put 0 in, I get 0 out. 1, I get 8.4. 2, I'm going to get 16.8. 3, I'm going to get, well, 3 times 8 is 24. 3 times 4 is 12. So it's probably 25, something like this. 8.4 times 3, 25.2. Okay, so we're going to have some spots on my graph here. So 0, 0, of course, we'll have a spot there. I'm going to put all of these in red, so I'll have a dot there. And let's put just 1, 2, 3, and 4. And then I'm going to put, let's go, here is 10, 20, and 30. Okay, so 1 hour, I get 8, so that's going to be about there. 2 hours, I get 16, that'll be about here. 3 hours, I get 25, that's about there. And again, this is Elena's. So we have Elena. Now let's do Jada's. So Jada's getting $7 per hour mowing her neighbor's lawns. So I would have 0 here, 0 there. And this could be y equals 7x, where I have my money and I have my hours. So I put 1 in, I get out 7, 2 would be 14, 3 would be 21, and I'm going to graph all these in green. So same origin here, but I'm actually going to have less this time. I'm going to have 7, and then I'm going to have less again. I'm going to have 14, so I'd be here, and then I'd have 21 for 3, so just about here. And so each time you can see Jada is making less money, which makes sense. That my table and my graph would all be lower for Jada. All right, what is the rate of change? This is a new vocab word. What is the value of the rate of change? Let's box this up, and this is slope. What does this value mean? So if I come along here and the change is a plus 8.4 and a plus 1, that is my rise and my run. So my slope here for Elena, my slope, Elena, slope, is going to be 8.4 divided by 1. If I want to put units on it, this is kind of nice. This is $8.4 per 1 hour. That's a nice thing to add on to my slope. So I have dollars per 1 hour. You divide that out and you basically get $8.4 per hour. That's how we could calculate slope. And then conversely, we literally have the slope built into my sentence here. This is slope. The word per really tips us off. Per usually means rate or slope. It's some sort of change. Something per something. So for Jada, my slope would be $7 per hour. All right, using your graph or table, determine how long it would take each person to earn $150. Well, that is not going to work for us. So on my graph here, I would have to go up to 150, which seems like it's going to be off the chart here. So let's go up here. So if this is 20, 30, I would have 40, 50, 60, 70, 80, 90, 100. Well, when am I going to hit this 100? Like, I've run out of page. When are these two lines going to hit that 100? So Elena looks like she's going to hit it here. I mean, see how I'm extending that? I messed up my next page. And Jada is going to hit it much later, so I take Jada and I line hers all the way up. And so I have Jada and Elena hitting at these two different spots. If I brought this down, this should be the time. So I could just bring this down. I bring this one down. Kind of a ridiculous situation we're in here. My graph is this whole thing here. I'm way off the screen. Okay. So I bring these down. I'm going to bring this one over, and I'm going to try and count how many hours. So my estimate is, if this is 1, 2, 3, 4, 5, 6, 7, 8, I'm going to guess 8 hours here, 9 and 10 hours there. So I'm going to guess that it takes 8 hours to get to 100 and 10 hours to get to 100 for Jada. I don't actually think that's true because if I multiply down here, that's not quite accurate. I think my graph is a little bit off. So I could take, I'm changing this to 100 because that's how far I could reach on my graph. And my guess was that Elena was 8 hours. So let's plug that into her equation. So her equation was a y equals 8.4 times x. So I'm going to put that 8 hours into my x. And I get y equals 8.4 times 8. And I can tell you already we're going to be off a little bit. That's not quite the number that I want. Let's go here. 8.4 times 8, 67.2. That's not quite 100. My graph is off. Now, what if I wanted to graph it and actually figure it out that way? Or use the equation, I could actually just say, hey, instead of plugging in the x, I could plug in my 100 for the y. So I could say, hey, take the same equation, y equals 8.4x, and I put this 100 into the y, and I say, hey, 100 equals 8.4x. Now, there are some rules to solve here. This 8.4 is multiplying the x, so I could just divide by 8.4. I could divide by 8.4. These guys will cross out because, let's check that. 8.4 divided by 8.4 will just give me a 1 next to this x. So I'd just end up with a 1x. So I'd have my x is now alone. I've solved for it. And then what's 100 divided by 8.4? I get 11.9. So it seems like Elena would have to work 11.9 hours to earn $100. $100. How much would it take to earn 150? I'd do 150 divided by 8.4. It would take her 17 hours, 17.8 hours to earn $150. It's a lot of time. All right. Claire and Han have summer jobs stuffing envelopes for 2 different companies. Han earns $15 for every 300 envelopes he finishes. And Claire's earnings are seen in this table. So let's create a table for Han here. So I have 300. I have my envelopes. And I have my money. All right, so if I finish 300, I get 15 bucks. If I finish 600, I would get double that money, so I get 30 bucks. If I finish another 300, I would get 900. So I'm just making my jump up here, plus 300 and plus 300. And then this is plus 15 and plus 15. So then I would have 45. Now, I'm just curious how much is Claire getting added on here. She has a plus 50. Ooh, that's nice. She's getting paid 50 bucks. But how much is she adding over? Ooh, she's adding 500 over here. That's a lot that she has to add on. So I can see right away that my slope and my slope over here are different. So the slope here is 50 divided by 500, because this is my rise and my run. So I have 50 divided by 500. What would that give me? I think that's 0.1. 50 divided by 500, I get 0.1. Now, what are the units on my 50? That's money, and this is envelopes. This is letters. So this is 0.1 dollars per letter. That's what I learned there. And then for Han, what is his situation? Well, he is getting a rise of 15 and a run of 300. So that would be $15 per 300 letters that he has to fold. So I do that. 15 divided by 300, and I'm getting 0.05. 0.05 dollars per letter. Okay, now they want us to create a graph to show how much each person makes after stuffing 1,500 letters. So let's go ahead and start our graph here. On the bottom, let's put our envelopes. So I know I have to get up to 1,500. So let's jump by 500s. So this could be a 500. And then this same jump here could be 1,000. And then I could have another jump over here, be 1,500. And this is my envelopes. Up here, let's do my money. So I have my money going up. Let's see how much I can get up there. So I start off. Since these are proportional, I'm pretty sure I could go in the center here. For Han, I'll do red. And for Claire, I'll do green. For Claire, green. Okay. Now, I have Hans is 300 is 15 bucks, and we got to get up to 90 bucks for sure. But if I'm going all the way up here, I'm going to need to get higher than 90. So let's actually top off at maybe 150 bucks. Let's try and keep it safe. So let's put we'll have $100 here. That's 100, and then maybe this is 200. I don't know how high we'll get. So this is 50, and then this is 25. Because Hans is really low. So half of 500 is 250. So Han is 300. That's here, 300, and he's only getting 15. So that's down here. So that's a real low amount. Oh, whoops, I'm supposed to be in red. Sorry. And then 600, so that'll be right about here. 600, 700, 800, 900. So 600 here gets me 30, so that's just above there. All right. Then 900 gets me 45. So 900 is here. And 900 gets me 45. That's right here. So I'm barely creeping up for Han. Are these in line? Barely. Not really. This one seems a little too high. Okay, so maybe this one was too high. This is my Han line. Let's see what we can do with Claire. Claire is 440. So 400 would be about here. And 40 is about there. So maybe like that. And then Claire has 900 is 90. So 90 could be here. And then I'm doing a little better with Claire's. Claire has hers go like this. Now, when we look at our 1,500 envelopes, we go up. This is the level for Han, and this is the level for Claire. So that's how much money they're going to get. Claire is clearly getting paid a better wage than Han. I wish they'd given me like some graph paper to do this. So it looks like Han is getting paid about $100, and Claire is getting paid maybe $150, something like that, ish. What is the value of the rate of change? So we've actually already calculated that. The rate of change is the slope. So I will let you write that down. We know that Han's slope is a rise and run. The rise is money, and the run is letters. I've already calculated that up here, so I'll let you rewrite that down here. You'll have to fill that in. And then Claire's has the same setup. She has some money, and she has some envelopes. And what does that equal? I'll let you write that in. Using your graph, determine how much more money one person makes than the other. So it looks like Claire makes more, and we know she makes more because she's making the slope that we calculated up there. She's making basically 10 cents per envelope, and Han makes only 5 cents per envelope. So if I was doing 1,500 envelopes, I could actually take these and multiply them. So I would take this and I multiply it by that. So that's 0.1 times 1,500, and this one would be 0.05 times 1,500. This is the equation way to calculate these out. So if I take 0.1 times 1,500, whoops, 1,500, I'd be paid 150 for Claire. I think Claire was in green. So her total would be 150, and then this guy here would be paid 0.05 times paid only 75. So I was a little high on my estimation for Han. Now when we looked up here, we thought Han was making 100, but we must have graphed this a little poorly, and we should have been lower here. And then Claire, we were spot on with our 150 estimation. All right. Now, Tyler, this is where we're going to let you test this one out yourself. So I want you to create a table with your X and your Y. Start with your 0, then your 1, then your 2, and you're going to create a graph here, and go ahead and test this out yourself and see how it goes.